Today we got hard problem 862 shortest subarray with sum at least k given an integer array k, return level shortest non-empty subarray with sum at least k. If there is no such subarray, return 1. Subarray is contiguous part of array 10 to 5, also negative numbers. I mean, this is not Kadane's algorithm. Not sure. Not sure, maybe. Something to do with Kadane. I'm sure a bunch of you watching know what that is. That's for maximum subarray sum. Let's say we start Kadane from some position and we get to a position where we have at least k. Right? What if we move? That's not monotone, like if we fix one part. Well, that's the first subarray, but yeah, I think the sliding window, basically Kadane, so we move right pointer until we have at least k. And then we shrink left pointer until we have at least k. And then we move right pointer until we have at least k. And then we move left pointer until we have less than k. Guess that should work. I could not prove this to save my life probably, but okay, and then let's say I don't know what, while r is n, and let's have some sort of a sum. Right, and sum is less than k. Sum plus equals nums r plus plus. Ans if sum k and ans minus 1 or r minus l under ans r minus l while ln and sum over k. No. Then we want to do sum minus equals nums l plus plus. This should work, I think. No, it doesn't. Okay. 150. Oh. That's great. Now if ans minus 1 or, now what's r minus l, because if r is 5, sucks. Oh. Maybe just do this. Seems simpler. What? 50, that's... What the hell? Yeah, okay, that's not gonna work. Oh my days. I mean, if there is... It doesn't really work like that. Like if there is an array of length, whatever, 10 that has it, or even 2, doesn't mean 3 is there. And if 3 is there, doesn't mean 2 is there. It's not monotone, because you could have like 20 minus 10 and 20, right? And you need whatever 30, right? So 1 doesn't work, 2 works, 3 2 doesn't work, and 3 works. So what is that, my brother? No hints. That is amazing. And 32% acceptance rate. It's gonna be some trick, but I'm not sure what. Like, how can you reuse that answer? Because when I move right pointer by 1, L could be 0. If I move it by 1, L could be 2. And if I move it by 1, L could be minus 1. So what is that, my brother? It's so weird. It's been 10 minutes, so I should look at the hint, but I don't really have time. Like, let's say That is weird, bruh. What the hell? Not sure what the trick is here, honestly. Because this is not gonna work, because the left pointer can move here and there, but there has to be some pattern in it. Something. Like, let's say R is somewhere, and shortest ending at some position, right? Well, that can, if I move R by 1, shortest L, you know, if it's large, if it's positive number, then L might decrease. And if it probably will. But if it's negative number, then L will move by 1. But then, wait, but then since it has to move by 1, then it's not gonna be as short as the one at ending at R. Like, okay, let's say we have, like, I don't know, right? And then I have some subarray ending here, right? And that's whatever shortest with sum over 1, right? And then, right, let's say I move here, and this is positive. Well, the index for sure then has to move, or yes, it has to move, because if there would be a negative number here, we could skip it, right? So the index for sure moves, for sure it moves, right? And if it's a negative number, right, then the sum will be less, and answer for ending at R will be longer than this answer, so we don't really care. But we still need the answer for this, and that sucks. Because if it's positive, the pointer moves to right, the left pointer moves from here, whatever, to here, and even all the way up to here. But if it's negative, the pointer moves to the left, and we need to know where the pointer moved. And like, okay, that was 4, and then could we somehow get a shorter one? Well, to get a shorter one, okay, wait. So, to get a shorter subarray, right, which could possibly include the -12, possibly, like, okay, so what I'm thinking is that, okay, we need to move the pointer for this to left, so it's obviously not gonna be shorter. But what if there is another number here that could theoretically go through this, like this previous border? If we need like less of a sum, because okay, so the theory is in Kadane that we just take all numbers and whenever we get to 0 we cut it because it's useless, right? We don't need the negative part because it's gonna decrease our sum. Now with this it's not so simple that we go under k and suddenly we have to do, can we do that? Can we still do this? I'm not sure. Let's try to test it. So let's have like a R for now and we do this. Probably need L or something. So nums, no, sum plus equals nums are plus plus. And now if sum, yeah, first we even have to get there, so we cannot cut the first part because it might be I mean, when we get negative, we cut it, I guess. Then sum is 0 and like L is R. Or ans is over R minus L, then I don't know what I'm even doing. Yeah, still doesn't work. I have no clue. Minimize size subarray. That uses binary search. Okay. Yeah, that's fair. I mean, that's fair. So oh. What? What? What the hell? Isn't that still slow? We store prefix and ending index. I picked the hardest possible problem for not having time. Okay, let's see the demo because... Okay, add no valid subarray, add sum to 0, okay. -1, sum decreases, so you add like 1, 1, okay. Add nums 2, cumulative 3 over k. But why couldn't you pick what? No, that cannot work. Oh, so you just throw it out. So you just leave the options, but once you used... Okay. That's smart. That is smart. I mean, man. Okay. Okay, that's good. That's pretty good, I guess. It's pretty good. Every time I forget this, and every time I forget this, I say every time I forget this. It's ridiculous. Let's see if it's whatever. So max, okay. PQ push. N+1, and now while not PQ empty and sum minus, or should I say plus, PQ top first is larger than or equal to k, ans min ans PQ top I minus that, PQ pop, and then PQ push minus sum, and then I, and then nums I, and that's it. And now if ans n+1 minus 1 I otherwise ans, That is weird, bruh. I don't understand that. Now one case will pass, but it's not enough. Maybe like this. Still don't work. So first you push 0.56, then you push 1. Now you push 56.0, then you push 45.1. Uh, 87, 87.2. I don't quite understand this. $126 and minus 35. Okay. I mean, I wanna subtract How is that possible? What? It should be. What the hell is happening? Zero. The update should be done first. That's why it don't work. If I do PQ insert, this should also work. Okay, no. Okay, this should work. I mean, Yeah, I mean that was the trick, but whatever, I guess. I guess some should be long. Now tell me they don't cast the reason. What? Ans is long. Ans is not long. Get away from me, bruh. Oh my god, bro. How am I supposed to get this? Are you kidding? That is ridiculous. I mean, you could think about that, I guess. I mean, that's fair because once, yeah, okay. I mean, that's pretty easy. Okay, whatever. So now, how did they optimize with DQ? Or they did some binary search and monotonic stack? That sounds crazy, dude. Then you want to maintain what? Increasing or non-decreasing sequence? What? What is that, my brother? Rightmost entry where the sum is at least what? Sum is what the hell? Hell nah. Oh my god, bro. Okay. I don't have. This will take me 1 hour to process. I'm just gonna write you editorial for this and whatever. I have to go. I want to do other stuff. I mean, and you search for, you maintain increasing prefix sums and you find the first rightmost one that is greater than or equal to current sum minus k. So if I subtract that from the current sum, I get at least k. What is that dog shit? And why, like, why would it work though? What? Prefix sum. All prefix sums blah 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 have to be less than the current blah 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 to make this worse blah blah blah. We remove that are greater than. Okay, this approach to the both prefix sums and there stay in increasing order. Once we have this ordering, we can use binary search to efficiently Sum is the difference between our current by keeping track of the show. What? Running cumulative sum. So while running cumulative sum is less than or equal to this, then we skip. I mean, couldn't you do that with like bisect? So you find candidate index. I might. What? Why? What is this shit? Oh my god, bruh. Okay. At each ending position, we want to find shortest subarray ending there. How to do it faster than trying all prefixes? Well, we store okay, how to do it faster than trying all prefixes. Now, why is trying all prefixes bad? Because let's look at prefixes we are trying multiple times and do not have to. These are indexes such that we already considered them as starting positions of subarrays ending at sooner position. Clearly, if they would form a subarray with sum greater than or equal to k ending at current position, subarray is larger than or longer, whatever, longer than if they would form a subarray with sum ending at clearly the subarrays ending at the current the subarrays with sum over k ending at current position are longer than the ones starting at the same index and ending at an earlier one. So we maintain a stack, we maintain a priority queue of pairs sum and then I don't know, index and the current cumulative sum, and we put 0 minus 1 and we initialize the priority queue with for each position we first update the for each position I we first update the cumulative sum with nums I, and then remove all indices from remove all pairs from the priority queue such that cumulative sum minus prefix sum is larger than or equal to k, and consider each I minus index as the longest or shortest subarray with valid sum. That's probably approach, but whatever. Note: this is possible to be done with monotonic stack plus binary search, and this and that idea can be quickened, fastened, can be improved to linear time complex with which also has a O of n log n time complexity, but it can be improved to linear time complexity with dq, but I do not understand it yet, so go read the editorial. Okay, of n log n, since for each of the n positions we pop, so we push one element to the priority queue and pop possibly multiple elements from it, but each element is going to be popped at most once, so in total each element is pushed and popped at most once, giving us the O n log n time complexity. I mean, that's quite good solution, but maybe tomorrow, or maybe I don't know, never I will read the faster ones. This is like O n, since we store at most O n prefixes in the priority queue at any single time. Okay. Too much pain, and 46 minutes, and I don't even understand the linear ones. So okay, goodbye.